So in the coming few classes, we look at what is synchronization and what is synchronization in a mobile scenario in the context of mobile devices and servers and application servers. Okay. Earlier you might have studied synchronization in a different context, in the context of database management systems. Okay. You might have studied what is synchronization, conflict resolution and other such issues. But here we are looking at synchronization in a different context. The context here is to do with synchronization of databases in your mobile devices and the servers and the application servers. So we will be looking at what is synchronization, why synchronization is required, then what are the different types of synchronizations in mobile computing systems. Then we look at what are the different usage models, okay, actual scenarios in which mobile systems are used, okay, and how synchronization is done in those cases. Then we look at certain set of rules which are domain specific rules that are to be satisfied by mobile devices, okay, in order to synchronize successfully. In order for the synchronization to take place successfully, we look at some domain specific rules and what are the various file formats that are required at the devices is also what we will see. Then we will look at synchronization and conflict resolution strategies. Okay, what are conflicts and how do we eliminate them during synchronization. Then we will look at synchronizer, a particular component that performs synchronization. Okay, we look at the functionality of a synchronizer. Then we look at mobile agents, what a mobile agent is, and as an example we look at aglets. In fact, aglets were introduced by IBM way back sometime in 2004, okay, to perform distributed computing. Okay, aglets perform distributed computing. They may not be as powerful, but let us say you are running a client server application, then all the functionality of the server has to be on a single machine. But in fact you can distribute the functionality of the server on different machines, and then an aglet can be sent, a request in the form of an aglet can be sent, and that aglet would be collecting the results from different machines. Okay, each of them can synchronously perform a different task, and the entire results together can be collected back at the client, at the requesting machine. Okay. So aglet would roam from one machine to another machine, collecting the results as it does that. Okay. So in fact it is a tool for distributed processing. Some of the tasks could be done by one machine, other tasks can be done by other machine. Okay. And finally the results could be sent back to the requesting machine using aglets. Okay. However, for some reason aglets were no more used. Okay, they were no more updated. However, when you do a project, you can easily consider rewriting that in an aglet, so that your project, which is now centralized, will become distributed. Might become distributed. You have an aglet framework, and like you have for applets or servlets, aglets also have a life cycle and some methods indicating when they should move from one machine to another machine, which machine they should move, all that source and destination. Okay, you can refer to that out of interest. Okay, yeah. In fact, there is a separate website that's maintained for aglets along with the aglet toolkit. You have an aglet toolkit along with the documentation. Once you download that, it is a matter of writing your Java code within the aglet, so that it migrates to some other machine and performs some computing. So that aglet. it is to do with the processing, actually, processing across different machines. Okay, in fact, not information on a single machine, but probably processing on different machines, and the results would be collected back by the requester. But, yeah, it's similar to that, very similar to that. Of course, maybe the reason why they discontinued is also that powerful tools like your platforms like your Hadoop have come up. Okay? Maybe the other issues like licensing and validation issues also. Then we look at finally what is an application server. An example of an application server in a mobile context. Okay? In a mobile context, what an application server does. So these are the topics that will be looking. But before we talk about synchronization, we need to look at replication. That data replication involves in copying data. After copying to another data, from at one location the data has been copied, copying that data to some other location, that is recopying the data. Okay, recopying the data is replication, and it could be done from one machine to many machines. Okay, data has already been copied to one machine, from that machine we can copy it again to different machines, or it could be done from many machines to many other machines. Data has been copied to many locations, from those locations they are again copied to other locations. So one to many or many to many. Examples are copying of the video tutorials or music files or other files across different locations. Okay. Now again, full copying refers to copying the entire set of records, while a partial copying refers to copying only a subset of the record. Okay. Actually, in this context, we need to understand why replication is important, where replication is used in a real time scenario. Okay. In fact, you can understand that whatever data we are getting is from your regional servers. It is not from a central server. They will not generally be a central server that serves the entire world. Okay. In fact, there are so many servers. Okay, there are so many servers across continents, then across countries, then across states, across regions. You have so many servers. Okay. So what we are getting actually is from a server that is closest to us. That is why we are getting the requested files so fast. Otherwise, if everyone has to access the same server which is in a very far off location, then there will be a lot of latency, lot of delay. But why are we able to get so fast? Because many servers are maintained and same copies of the files are maintained on different servers. Okay. It is to be understood that the data is replicated across all these servers. Okay. So data replication is a very important process. But once you replicate the data, once after you copy the data from say a main server to many servers, to say 1,000 servers across the globe, you have copied the data, you have replicated the data. But then the next problem would be to maintain synchronization between that main server's data and all these servers data, all these regional servers data. Whenever data updates updates there, they have to be updated at these respective servers also. Okay. So that involves synchronization. So synchronization comes after replication. Okay, that's how synchronization is related to replication. Okay. Replication is necessary for access, while synchronization is necessary for consistency. Okay. For ensuring consistency of the data, we would require synchronization. And obviously whenever we copy the data, we said it must be according to some rules at the destination device. Okay, the copying of the data is governed by certain rules at the device at which it is being copied, at the destination device. And here you can see, in fact, two of the scenarios where data is replicated from a source, from a data source to a device, okay, and the other scenario in which at a larger scale it is replicated from a server to clients, many mobile clients. Okay. The first scenario is looked as only copying from one device to another device, okay, from a device near to it, okay, that is very near to it geographically. Okay. So in fact we call it a service provider. You need to look at the terminology. Okay. If the replication is done from a machine that is very near geographically, then that machine is considered as a service provider. Okay, it is considered as a mobile service provider or a local computer. Okay. And obviously it has to be either through a wireless or wired media. Replication can be done either wirelessly or through a wired media. Okay. And the device that is receiving the data, replicated data, is a mobile device at the other end. This is a simple scenario, similar to your peer networking, peer to peer. Okay, get the data from the nearest available node. That is peer to peer mechanism. The other mechanism is server to many clients. Okay, here you call it a central server, central data server, again connected through either a wired medium or a wireless medium. And from that the data will be replicated across many mobile clients. This is another scenario. And here you can see a 3-tier architecture where the top tier is the application tier. Okay, the application tier where your application servers reside. Okay, and computation is done across multiple servers. The next tier, okay, or your middle tier does synchronization, okay, and database retrieval. We have database servers and synchronization servers at the middle tier. And the last one would be the devices, the mobile devices. Okay. So whenever the mobile devices request these, the database servers are synchronization, the database servers which also perform synchronization, they will forward that to the application servers where processing is done and the results are returned back to the mobile client. Okay. This is a typical 3-tier architecture. In fact, when defining synchronization, okay, data synchronization is the process of maintaining availability of data. Okay. The first condition for synchronization to happen is maintain availability of data that is generated from the source, even in the absence of the source. Okay. Even if the source is not present temporarily, the data must still be available. Okay. So one condition is availability of data, then maintaining consistency between copies of data that are hoarded, okay, onto the client with the data from the source, which is the server. Okay. So server contains some data and the data that is stored on a client's mobile systems database. Okay. Mobile devices database. The storing of the data is called hoarding of data. So this hoarded data must be consistent with the data that is present at the server. So ensuring consistency is another thing. Okay. Next thing is without discrepancies or conflicts among the distributed data. Then we need to see that since the data, same data is copied across different devices, there must not be any conflict in the data that is copied to different devices. Right. And you can see, once we copy data from a source to a destination, we need to understand that it need not exactly be in the same form as that at the source. Okay. As an example, when you copy some images with high resolution, some images are there at a server at 640 by 640 pixels. Okay. But when you copy them to a mobile device, they may be copied as 160 by 160 pixels. On some other device that has still higher that supports higher resolution, it may be 320 by 320 pixels. Okay. What it means is, the data at the source need not be exactly same. The data at the mobile device need not be exactly the same as that of the source. Okay. The records may be in a different format at the source and in a different format at the device, because typically your mobile devices don't support high memory. Okay, they have constraints of memory. Okay, so a larger image on a PC, on your PC or a server, will be stored in a smaller form, much smaller form. When you want to stream a video onto a mobile device, okay, you will use the smallest resolution that is possible. That is enough for you to see. You need not use that high a resolution. So obviously reducing the resolution will also result in reduction in the size, storage requirements, right? But again, how do we ensure? Because on one machine you are copying as 160 by 160 pixels, another machine you are copying as 320 by 320 pixels. At the original source it is say 640 by 640 pixels. How do we ensure consistency between all this data is the biggest problem in synchronization. And why synchronization is required? Okay. Synchronization is required because it helps mobile devices to access data even when they are not connected to the source. Even when the device is not connected to a source or a server, still they can use the locally hoarded data, the data that is present on the local database of that mobile device. But one requirement to use the data is that that data should not conflict with the data that is present on the original source, And also synchronization helps in hoarding data from one device to another mobile device, or in fact one mobile device to another mobile device. You can either hoard data from a PC to a mobile device or from one mobile device to another mobile device. And when it is done at very frequent intervals for mobility, in conditions of mobility, you require that the hoarding be done very frequently. Okay, very frequently the data has to be updated. Otherwise, it will lose consistency. Okay? That is the necessity in case of mobility. In fact, large chunks of data can be maintained at a enterprise server, at a central server, and that could be distributed across several mobile devices. Okay, and they can be updated at regular intervals of time. But it is to be understood that the basic advantage of synchronization is that data is available even without the source, even without presence of a source. temporarily we can still access data. And we look at the types of synchronization in mobile computing systems. In fact, when we talk about the different types of synchronization, the synchronization can happen from a server to a client or from a client to a server. And it can either be full copy synchronization or partial copy synchronization. So you come across different scenarios. Here we are looking at the first scenario, which is full copy synchronization at the device, at the mobile device. When the server sends data, the server is sending data, and the updated data is sent from the server to the mobile device, whereby the device and the server's data are synchronized. Again, you can see we are referring to a single device, a nearby device. That's why we are calling it a mobile service provider or source. Okay, we are not actually calling it a server. Okay, whenever you are using the term mobile service provider or a data source, we are referring to a nearby system. And that is sending the updated data to the mobile device, okay, enabling synchronization. This is one scenario. And in another type of synchronization, we have full copy synchronization at the server with the device sending data. When the device sends data, we need to understand that sometimes even server has to update its data when the device asks that to update it. Okay, not always that client updates its data. Sometimes when a request comes from a device, then the server has to update its data. Okay. So in case of full copy synchronization, in fact the entire set of records at the server are to be updated with those at that of the client. Okay, whenever a client is requesting full copy synchronization, that means server has to update with the entire set of records of the client. Okay, that is full copy synchronization. Next thing is, again, in the next case, server is the source and client is the destination, but now it is partial copy synchronization. Okay, partial copy synchronization with no delay. Now the difference between full copy and partial copy synchronization is, in partial copy synchronization, only subset of data is updated, only the data that changes, only the records that are changed are updated. Whereas in full copy synchronization, the entire set of records are updated. Complete data is to be updated. Okay. So obviously partial synchronization is faster, is quicker. And again, you can refer to the terms uplink and the downlink in the diagrams. Whenever the client is requesting the server to update its data, okay, then it's uplink. Okay, our client is sending data that is to be updated at the server, that is uplink. And whenever it's coming from the server to the client, it is downlink. Okay, whenever the data is coming from the server to the client, it refers to downlink. And you can see in the second scenario, as soon as a copy is modified at the server, it is updated at the client's database, hoarded at the client's database. In case of partial copy synchronization with no delay. Right? Whenever there is an updation at the server, immediately the updated data is modified at the client. Whereas in case of full copy synchronization, it implies that it need not be immediate. Okay, the updation may take time. It need not be immediate. Okay, immediate as soon as the client connects to the server. And looking at the different types of synchronization, now the point here is who is initiating the synchronization, okay, and who has to perform the synchronization, who has to perform the updation. Whether the client is initiating the synchronization process or the server is initiating the synchronization process, where the data has to change, whether it has to update at the client or at the server, or it has to update at both places. Getting me? Whatever happens, it leads to synchronization. So all these are scenarios in different types of synchronization. And the very first type of synchronization is two-way synchronization, which is also called fast synchronization. In fact, two-way synchronization is also called fast synchronization. This will not be mentioned too often. So chances are that in your exam he asks you about fast synchronization, you don't know that two-way synchronization is nothing but fast synchronization. If you know that, you will write. Okay. So in two-way synchronization, either partial or full copies of data are synchronized at either end. If there is any change in data at the server, that is updated at the client. If there is any change in data at the client, it is to be updated at the server. So both ways. That is two-way synchronization. Right? And remember, it can happen parallelly also. Parallelly, some updations are going on at the client and the server. So the updations from client are sent to the server and the updations from server are sent to the client at the same time, synchronously. Okay? So that is two-way synchronization. And two-way synchronization is very fast. Almost many mobile systems use the two-way synchronization mechanism. For example, whenever contact list, the list of contacts, okay, or the PIM software maintains a list of contacts. Okay. Whenever any information changes, that PIM information changes at the server, it has to be updated at the client's database, okay, local database of the client. Similarly, whenever there is a change in the mobile device's database, it has to be updated at the server. Okay, this contact information has to be updated at the server. This is two-way synchronization. The next type is server alerted synchronization. Server will alert the client that there is an update, and the client has to send a request, and the client has to pull the data from the server. Okay, server will only intimate the client that, for example, an email, there is a new email, but it will not actually send the email to the client. Then the client has to pull that email from the server. Okay. In fact, actually before synchronization, there are two, there is something else called data dissemination in mobile computing. Data dissemination refers to how data is transferred to a mobile device. Okay. There are two mechanisms. One is push based dissemination and other is pull based dissemination. Okay. And in the push based mechanism, server will be pushing the data at regular intervals of time. Client will not request. Okay. It is similar to the SMSs that you have on your mobile phone. Periodically you get SMSs. Okay. that is the server is using a push based mechanism. On the other hand, pull based mechanism is when the client pulls data from the server. For example, you send a request for the current scores update or something, that is pull based mechanism. In fact, a combination of these two is a push pull mechanism which is generally used. Okay, for example, in a stock market, client keeps sending something requirements and the server will periodically send the updates, because you will have stock market updates every 5 minutes or something, that will be sent to the client. So combination of push pull mechanisms is also used. In fact, before studying synchronization, it's better that you should have studied data dissemination, but it's enough that you understand that there are two mechanisms, push based and pull based. Push based is from server to the client and pull based is from the client to the server. And you can see whenever the server has a new email, it alerts the client and the client pulls the email from the server. Okay, that is server initiated. The next one is that is server alerted synchronization. Okay. The next mechanism is server initiated. Okay, first is server alerted synchronization, next is server initiated. In server initiated, whenever there is a change in data at the server, it automatically pushes the data onto the client. Client will never be required to pull data from the server. Server itself will automatically send the data whenever there is a change. Whenever a new email arrives, it sends the data to the client. Okay. So that is another mechanism that is initiated by the server. It is server initiated. And the next one obviously is to do with the client. As you may understand, it is client initiated refresh synchronization. That is, this time whenever there is a change at the client, he will inform the server to update itself. Okay. This time the updation takes place at the server. This time also it is one way, but from client to the server, the client will initiate the update process. For example, whenever personal information or something has changed at the client's end, it will push that changed information to the server, and next time it needs to obtain it, it gets that updated information back from the server. Another example is whenever a new device enters a network, okay, it has some configuration parameters. So the mobile device will send those configuration parameters to the server, and the server has to update the configuration file. It has to maintain a copy. So this is here it is to be understood that the server has to replace its existing data with the new data that is sent by the client. This is called client initiated synchronization. In fact, it's refresh synchronization. We have another term, refresh, which means completely change the data. Yeah, with the new data, replace existing data completely with the new data. Okay. Even if one or two records have changed at the client, the server will be required to replace all the records in the case of refresh synchronization. If you don't use the term refresh, only the updated records are to be changed at the server. At the server, any added records or removed records, updated, changed records are to be modified at the server. In case of normal client initiated synchronization. In case of client initiated refresh synchronization, we have seen the entire set of records are to be replaced at the server. As mentioned before, in client initiated synchronization, which is also one-way synchronization from the client, whenever any information changes at the client, it communicates with the server for sending its modifications. And this is different from client initiated refresh synchronization, in that only files which have changed recently are sent to the server for modifications, whereas in the case of client initiated refresh synchronization, even if one or two records change at the client device, all the records are to be updated at the server. And examples of data that could be updated, that could be sent from the client to be updated at the server, are when device configuration changes at the client, or the client mobile device sends any new emails or new ringtones or music files that have arrived to the server, either periodically at periodic intervals of time, or immediately as and when it connects to the server. Then we have refresh from client for backup and update synchronization. In this, whenever the client wants to backup its data, for example, let's say the battery levels are low for a client device, then the client decides to backup its data. Then the client will initiate synchronization and sends backup to the server. Example of data that could be backed up is the computer or the mobile device sending its hoarded contact and personal information, the information stored at its local database, either at periodic intervals or immediately as and when it connects to the server. Finally, we have slow or full data copy synchronization. In this type of synchronization, the client and server are regularly compared for each data fields, and any conflicts are resolved as they are synchronized at both ends. Obviously, even here synchronization has to be at both ends. Whenever client's data changes, it has to be updated at the server, and whenever server's data changes, it has to be updated at the client. And this is different from fast or two-way synchronization, which is only partial synchronization. The slow synchronization will definitely ensure that there are no conflicts in data, and it's definitely perfect synchronization. And while fast synchronization might take place immediately when a device connects to the server, a full copy synchronization generally takes place in the idle state of the device, but not on immediately connecting to the server. And because a thorough check has to be made of each data fields in records before the synchronization takes place, it is slow. It's also called slow synchronization. An example of a platform that uses or supports synchronization is Sun Java System Mobile Enterprise Platform 1. The various reference to the various methods for synchronization is given. The link is given here. Then we look at what are the various formats whenever a source synchronizes with data at the destination. then the source has to do that according to the format that's specified at the destination. So what are the various possible formats for synchronization? One thing is database records, and whenever searching or querying by some particular fields, for example, is required, then database records are used. And it is to be noted that the same databases need not necessarily be used at the server and the client. For example, at the server it could be DB2, while the client could be using DB2 every place. Then in flat file synchronization, files have to be read from beginning to the end. In order for any search, the file has to be read from beginning to end. Even for observing any changes, in case of synchronization, the files have to be read from the beginning to end. And XML or HTML files could be used at the server, while at the client a compressed format such as binary XML, WB XML format could be used at the client. And again, they can be device specific storage formats. For example, the server could be using Apple audio codec format for storing some music files, or the .wav wave format. We know it has higher size, while at different client devices the formats could be different. At one client device it could be .mp3, while at another device it could be MP4. Similarly, for calendar and other contact synchronization, for example, we could use Outlook at the server, while at the client devices it could be formats like vCard, vCalendar, etc. at different client devices. Having looked at what are the various possible formats, data formats for synchronization, now we look at different usage models for synchronization in mobile applications. We look at how practically models are used in real world scenario for synchronization. We look at 4 usage models employed for synchronization in mobile computing systems. The first type, the synchronization is between 2 APIs within the same mobile computing system. It could also be between number of APIs within the same mobile device, in fact. And an example is synchronization between the PIM, Personal Information Manager API, and the email API. Whenever a new email comes to a device from another device, then it accesses the email API in the device. Then this email information would be automatically updated with fields such as the name and email are automatically updated at the PIM API. Then the email API, the PIM API would be accessing the email API and storing these details. Again, at a later stage, when an email is to be sent to a person, because his name is already stored as a record using the PIM API, so the email API then uses his details to get his email ID, where the mail is to be sent based on the name of the person. So the email API will then require to contact the PIM API, and it uses the same data records from the PIM API. A very good example of this type of synchronization between APIs within the same system is how Google Chrome, the browser, synchronizes the data with its with a Google account. For example, we have a Gmail account and we give several information such as the first name, middle name, last name, address, age and other details. So whenever you need to fill up a form, you might have observed when you are filling up a shopping order or anything, then immediately on entering your email ID itself, you can see that many of the fields are automatically filled up. You need not again enter the first name, last name, address and all those things. So how does this happen? This happens because your browser settings are synchronized with your Google account settings, and we know the procedure to set up is given here. We click the Chrome's menu button and then sign in to your Chrome, then go to the settings within that advanced sync settings, and then we can control how the synchronization can be done. In fact, without even without doing all this, Chrome automatically synchronizes our apps with the autofill data, okay, automatically with the Gmail account. But however, you can see here only password is encrypted. It appears as some stars, but not all other information like your address and other details will directly appear whenever you type in the email. But however, using these settings, we can also specify optionally to encrypt all data. This is for the purpose of additional security, because when you send the data, we should make sure that it is encrypted for additional security. And there is also another option for setting a separate password for encryption within the Google Chrome sync settings, advanced sync settings. So coming to the next type of usage model, coming to the next usage model for synchronization. Here the synchronization happens between a device and another device, a nearby device. Okay, and another name for this is personal area synchronization. So obviously, whenever a device is within the range of another device, then the synchronization could happen using Bluetooth or radio frequency transmission or other mechanisms. And here the synchronization with nearby PC could happen through a serial port using a cradle. Once the device is placed on the cradle, then it automatically synchronizes with the nearby device, or it could also be through a wired connection to the PC. The synchronization could happen either wirelessly or using a wired connection. Then the synchronization with the nearby device or a computer could happen using a personal area network that uses protocols such as the Zigbee or something else called 6LoWPAN protocol. The synchronization can happen. And here a case study of synchronization using Bluetooth is given. In fact, the entire procedure for synchronizing your device PIM information with another device connected using Bluetooth. Both the devices have Bluetooth set up on them. Then whenever some information is once these two devices once the PIM database of both these devices are synchronized, then whenever any change in contact information, any addition in contact information or email happens on one device, it will also automatically happen on the other device. In fact, you can do this out of interest. You can do this as a small case study. Try to see after establishing synchronization whether all the changes that you have done on your any changes on your mobile device are also happening on the other device. So it works like magic, and the procedure is given here. And we use PIM synchronization. Okay, and next we can select the PIM that we want to synchronize, because there could be more than one PIM softwares residing on the same device. So there is also an option after the Bluetooth device selection, connection establishment, and then PIM synchronization. Then we have the option to configure, okay, within synchronization which is the PIM we want to synchronize. And then once it gives us a message whether access to PIM synchronization service must be allowed, then when we say yes, from that point of time both the devices are the PIM information of both the devices are synchronized. And complete information of how to do this is given in the reference link mentioned here. So in the third usage model, the synchronization is between a remote system and device. So obviously whenever a server, okay, that's a mobile service provider, is at a remote location and the device wants to connect and synchronize with that server, then it could happen obviously through an internet connection. So device data records synchronize with the mobile service provider service records, and also the server or systems synchronize their data with the mobile device. So it is two-way. So device records are synchronized with the service provider's records, and also the service provider's records are synchronized with the mobile devices records. They also synchronize with the mobile device records, and so it's two-way, both ways. And the device can connect to the remote systems on internet either using wired connection or using a mobile service provider, an internet service provider, okay, or using a Wi-Fi. Using Wi-Fi you could indirectly connect to the internet through the service provider. And one example of this type of synchronization is IntelliSync, which allows for wireless email synchronization between a remote device, remote system and a device using a SyncML language. So whenever you want to set up remote synchronization, then you have to learn the syntax of few of the tags and functions of the syncml language. So another example, a very good example of a remote synchronization is in the scenario of very large corporate hospitals. In fact, it's not small hospitals, but something like multi-specialty clinics where there are a number of specialities, number of wards, and many rooms, okay, and lot of information to maintain. In such a scenario, whenever there might be nurses who visit patients. In fact, we can't even ensure that the same nurse attends the same patient at different times. In fact, the nurses also keep changing. So whenever a nurse visits a patient, they have to enter the information of the patient. For example, his blood pressure and sugar levels and all that into database. Okay. Now, though it's being presently done mostly manually, but it could also be done directly on mobile devices. The information could be stored on their mobile devices, and at the end of the day, all the nurses, okay, send this information to a central database, and then after that the nurses can synchronize the mobile devices with the database, so that other nurses might get the information from the previously visiting nurses, so they can get any new information about the patients. So every time at the end of the day, the nurses have to send their information to central database, and the next day they synchronize with the database to update on their devices and get the information. And Apex SQL data diff, okay, software and SQL server data comparison and synchronization tools are used for the purpose of synchronization and also detecting any conflicts, detecting and resolving any conflicts in the data, because it's absolutely critical. A patient's information is very critical, and any conflicts in the information have to be removed for synchronization to take place. And then once these data differences and conflicts are resolved without errors, okay, then obviously the synchronization takes place. And in fact, these tools also provide other facilities like synchronizing with live databases, okay, and compressing the information for data backups, and generation of comprehensive reports periodically on any conflicts or data differences, and also in fact create the configuration files automatically, the synchronization files, create synchronization files and automatically execute them for absolutely perfect synchronization between the devices and the central database. So in the last usage model for synchronization, this synchronization through a local pass-through system. In this type of synchronization, the device does not directly synchronize with a service provider or a remote system, but it synchronizes indirectly through an intermediate local pass-through system. In fact, the device data records synchronize with the records of a remote system through a local device such as a PC. The device first synchronizes with the local computer using synchronization software such as ActiveSync or HotSync or IntelliSync, and using Bluetooth and protocols such as IRDA or Zigbee. And then the computer synchronizes with the internet using a direct wide connection or using WLAN, Wi-Fi and other mechanisms. The computer would periodically synchronize with the internet, and then the device synchronizes with the computer in order to update its data. It synchronizes with the computer, which is the local pass-through system in this case. So very good example of synchronization using a pass-through system is pass-through authentication of Windows system. Whenever Service Desk Plus is to be used, users have to log in and enter some information, and whenever the information whenever an existing user has to use this Service Desk Plus, then we can use pass-through authentication using NTML version 2, which using a service called NetLogon service will prevent the users having to enter their details again and again. In fact, the NetLogon service will be running on a pass-through system, and it will automatically determine whether the user is authentic or not, and the user does not have to remember his passwords, too many passwords, or give too many details. There is an Active Directory that's maintained using the NetLogon service, and using this pass-through system on which pass-through system on which this NetLogon service is running, authentication becomes easy, and a user can directly log in by just entering very less details. And details of how this is done using this particular type of service and the software NTML v2 is given in the link that's provided below. Next we look at domain dependent specific rules for synchronization. Why are domain dependent specific rules required? Because synchronization typically takes place between systems with different properties, on different platforms, and at different conditions. So some domain specific rules are to be specified to ensure successful synchronization and for the existence of data across different domains. So the first domain dependent specific rule is data synchronization in domain specific platforms and data formats. So the platforms vary from one domain to another domain, and so do the data formats. Here the data synchronization is between a data gathering domain which might be the source and a destination domain. However, the source and destination both have different platforms as well as data formats. For example, at a server, the operating system used could be Windows, while the records in a database could be stored using either DB2 or Oracle database format. While at the client, a copy of the database record at the client device could be stored in the XML format or the text format, text or XML format, while the platform at the client could be a Symbian or Android or some other client specific device specific operating systems. Then some rules have to be specified to synchronize between these different platforms and different formats of data. So the data in the mobile device domain has different rules for storage and usage when compared to the data at the remote at the server, at the destination device. So this is data synchronization in domain specific platforms and different formats. And the next one is data synchronization between one domain with one property of data. Okay, one domain with one property of data with another domain having a different property of data. This he terms domain specific data property dependent synchronization. Domain specific data property dependent synchronization. So it is specific to that domain and it is dependent on the properties of the data, or in other words the formats of the data. For example, at the server, a data could be stored as 16 bits in a 16-bit format. You could store a record in a 16-bit format at the server. A field, one field in the record can be stored as a 16-bit field. Okay, in fact, entire record will be much larger than that. But again, in the mobile device, the same field could be stored as 8 bits. Okay, as 8 bits. So this is to do with the properties, actually the property of the property of data. The properties of the data are different between the source and the destination. Okay, that is at the server and at the mobile device. Then again we have to define some rules to deal with the difference in the properties. Okay, this is another example of domain specific rules. The other one is synchronization up to the last successful act of synchronization. Okay, in fact, synchronization is considered successful when it has taken place the last time a device has the client has connected to the server. Okay, then the synchronization has taken place at the last time. Okay, that is synchronization up to last successful act of synchronization. Only then the synchronization is considered to be successful. Okay, if it happened at the last time of connection of the device to the server, then it is considered to be successful synchronization. The next synchronization occurs obviously at the next connection. Whenever the device next connects to the server, then the next synchronization would occur. The next is memory infrastructure dependent based You can remember it as MID, memory infrastructure dependent based synchronization. Okay. So it depends on the infrastructure and in turn the memory. Okay, the synchronization varies depending on the memory available at the server and the mobile device. Okay. For example, a server can store, okay, a domain specific rule could state that server maintains entire 8 MB of contact details, address book having complete details, okay, and its size is 8 MB, while the client's contact addresses might be limited to 128 KB. Okay. So what it means is only a part of that database can be synchronized, of the client's database can be synchronized. Okay, not the complete address book, but let us say for a particular client only 100 records from the server can be synchronized, because there is a limitation on the memory at the client. Okay, it has only 128 KB. So that 128 KB records could be synchronized. Whereas at the server it has a larger list of synchronized records, okay, because the server has higher memory for storage. Okay. So this is another case where synchronization is memory dependent. It depends on the memory of your device. So how many records you can synchronize will depend on the memory of the device. Okay, it is limited to the memory of your device. If only 100 records can fit in your memory, you cannot synchronize 200 records. You will synchronize what are the most recent 100 records. That's what it means. Right? And finally, you have something called synchronization with temporal properties of data. Okay. In synchronization with temporal properties of data, the domain specific rule, okay, domain specific rule states that the synchronization has to happen at specified interval of time, okay, and at a time that is specified by the domain. It depends on the domain. As a best example, flights timetables, okay, flights timetables are to be synchronized, can be synchronized every week. Okay, a client can synchronize with the flights timetables every 1 week, it would be sufficient. But on the other hand, with a weather database, if you have some weather related information, then the client will have to synchronize every day. Okay, every day we would require the weather. If it is a stock market, the client will have to synchronize every hour, probably every hour. Okay. So depends on the interval for synchronization. The interval for synchronization depends on the domain. Okay. So that is synchronization with temporal properties of data. Temporal properties of data. However, when you are using temporal properties for synchronization, we may expect some inconsistency. Okay, we may expect some inconsistency, but as long as this inconsistency, if there are no unaccountable discrepancies, other discrepancies apart from these temporal discrepancies, it is enough, it is good enough. Okay. Though some discrepancies are inevitable, okay, there will be some inconsistency in data due to during this temporal synchronization. However, as long as there are no other discrepancies, this is allowable. You can still use temporal synchronization. Okay. In a given period, you could synchronize. Right? Within a given period, you could synchronize. For example, one might be synchronizing slightly early and other might be synchronizing slightly late, okay, at some time. So you might expect some differences, but still the differences are not very large. Okay, that's what it means. So that is synchronizing domain specific rules with temporal synchronization. So having seen what is synchronization and the different types of synchronization and usage models of synchronization, we look at a particular case study of data synchronization architecture in Oracle. And here we can see a mobile client and a mobile server, and we can also see a sync client and a sync server. So sync client is a part of the mobile client, whereas the sync server is part of the mobile server. Also you can see two queues, one in queue and an out queue. The in queue is responsible for configuration information. Okay. Whenever a client changes its configure information or new clients add, then that information is passed through that in queue to an MGP, which is a message generator processor. Okay. And then it is updated in the database. Similarly, whenever any information is to be sent to the mobile client, it is sent from the database through the MGP, through the message generator processor. It is sent to an out queue, and from the out queue it will be sent to the mobile client. It will be updated at the mobile client. Okay. So you can see mobile client, the sync client is a part of the mobile client, while the sync server, in queue, out queue and MGP all constitute the mobile server. Okay. So this relates to the three-tier architecture that we have discussed a few slides ago. A three-tier architecture where we have an application server, and then we have synchronization and database server, then we have the mobile client at the three layers. So you can correlate this architecture with the three-layer diagram, with the three-layer architecture, okay? Three-tier architecture. We can see this is a description of the previous slide of the architecture, of the synchronization architecture in Oracle. The sync client and sync server work together to upload any mobile client changes, okay, to the mobile server in the queue. The sync client resides on the mobile client and the sync server resides on the mobile server. Okay. And the server places any modifications through the server places any modifications in the in queue and updates in the database. Similarly, it downloads any new data from the server to the client through the out queue. And the message generator and processor takes care of number of clients. Messages, any updations coming from a number of clients is taken care of by a message generator processor. And it runs in the same tier as the mobile server. And it executes independently and periodically based on some scheduler. Okay, based on some scheduling policy, it will be accepting any updations from the client, or it will be sending any updations to the client. And you can see anytime the mobile user synchronizes with the mobile server, the changes can be downloaded and applied to the client's database. Client's database is nothing but the database in the mobile device, okay, which we call hoarded database. Okay, hoarding of records in a mobile client. Okay, so whenever a client synchronizes with the server, any changes are downloaded. Okay, are in fact downloaded onto the local database in the mobile client device. And this is an example of a synchronization case study where we can perform synchronization using an Oracle client and a server, and we can specify different settings like the platform settings, the configuration settings, and we were talking about domain specific rules, okay, and conflict resolution strategies. Everything can be specified in this software. We can configure in the software. So once we configure, automatically the synchronizer will take care of updating the client, synchronizing the client with the server. And here we can see the platform name can be specified as Oracle Lite WCE. Oracle Lite is a Oracle version for mobile devices, and you can specify the conditions for automatic synchronization. What are the platform system events for automatic synchronization? First one is synchronize when the network bandwidth is greater than something. Then synchronize when the battery level drops below certain level. Say when your battery of your mobile has reached 15%, then perform synchronization, because they might be important data, and perform synchronization at that instant. Similarly, synchronization at a specific time or at a time interval. You can specify that the synchronization can happen at a particular time or between this time, like you do with your antivirus software. Okay, you can configure when your antivirus software will be updated. Okay, during which period, or even the absolute time can be specified. And again, you can see based on the network bandwidth, what is the maximum network bandwidth, okay, and what is the minimum network bandwidth for synchronization to happen. All these things can be specified.